So today we're talking about solving radical equations, which is kind of what we did yesterday anyway, but you want to get the idea. Radicals are special in our world. Okay, so this is kind of the beginning, is kind of a review of what you need to do to get rid of. So in other words, what's the inverse operation of addition? Well, the inverse operation of addition is subtraction. So if you were solving an equation like 2x plus 3 equals 7, if you had addition here, you would use subtraction to get rid of it. And that's what I'm asking for in these problems. Like this 2 here is multiplication. You would divide to get rid of it, and so on. So subtraction, the inverse is addition. Division is multiplication. So if you have a dividing problem, so 2x minus 7 over 2 equals 3, you would multiply by 2. This dividing, you're multiplying. Squaring, you square root, and this is today's, you square. Okay, so that's the basic idea. Now, we've done this a bunch with other types of equations. The basic idea is you need to isolate the radical. So that means if you look on one side of the equal sign, is the radical by itself, or are there other things over here attached to it, by addition or subtraction or multiplication or division or whatever? To get rid of the square root, you square both sides, you solve the equation, and you should check it back in the original to make sure you don't have any imaginary numbers in this. Alright, so you look for step 1. You look to see on this side of the equal sign with the radical, is there anything but the thing in the radical? No. So you're good. At this point, it's isolated. So you square both sides. That radical gets canceled out by the squaring, and you're left with 2x minus 3 equals 25. And you solve. That's it. Pretty straightforward. And x is 14. Something like this. So we're looking on this side of the equal sign. Is there anything there that shouldn't be? Well, here's the radical. So this 4 is not under the radical, and it's attached by addition. So I change its sign and add. And I'm left with radical 1 minus 3x equals 8. And we solve. So I just showed you how to solve it, and you can almost think of this as 1 minus 3x to the 1/2 power equals 8. And you simply solve it. So here in this case you would square, you would flip the exponent, right? Which is the same thing that's happening up here. Same process. So it's up to you which way you do it. Okay, those go away. I'm left with 1 minus 3x equals 64, and you solve. So x would be negative 21. Okay, you should go back and check. I really hate it, but you gotta check. So take a second, take that negative 21, plug it in, and I'll come back with the check visual. Okay, so here's the check. It's the same on both sides. When I plug negative 21 in for x, I get 12 equals 12. Okay, same deal on this one. This one gets a little bit more fun and exciting. This 1 has to go, so I subtract. But when I subtract the 1, I get x minus 1 equals 15 minus 7x. Okay, so it's isolated, so now I square both sides. Now we spent hours doing x minus 1 squared, so take a second, you tell me what it is. Hopefully you got x squared minus 2x plus 1. If you didn't, remember it is x minus 1 times x minus 1. You've got a square or box, however you choose to do it. Okay, so then we solve this. This is a quadratic now. It's got a squared. So anytime it's a squared, everything goes to the side with the squared. So I'm changing all these signs. That's 0, that's 0. X squared plus 5x minus 14. We solve x plus 7, x minus 2. So x equals negative 7, and x equals positive 2. So we got to check these. So take a second and check them. and see if they work. So here's the check. Turns out when I check the -7, the first one that I checked, the -7 here, put -7 here and here, do the math, I get -7 equals 9, so that's rejected. That one doesn't work. I plug this one in, I get 2 equals 2, that's good, so 2 is our answer. Okay, basic idea here is you have two radicals. They're already isolated. They're alone. So when I square both sides, pretty straightforward. 5x plus 2 equals 9x minus 14, and you solve. So this one actually looks harder than it is. So this is 0, that's 0, and I'm left with 4x equals 6. Unless I screw, 14, excuse me, equals 16. So divide by 4, 4 is your x. Go back and check it. Okay, so these two check. I get radical 22 equals radical 22. It's not pretty, but that's it. So something like this, just as another example, let's isolate it first, and then we will allow you to try this one on your own. Okay, so I'm going to subtract the x, change its sign. I'm left with negative radical 5 minus x equals 3 minus x. This negative has to be gotten rid of. So it's radical 5 minus x equals, change the sign of each one of these. So the x becomes positive, the 3 becomes negative. Okay, solve this and come back with some answers. Okay, looking at this one, factor and make sure when you squared, when you squared, you got x squared minus 6x plus 9. Don't lose that middle term there. Make sure that's a plus 9. When I did this, I got 1 and 4 as answers. Plugged 1 in, it doesn't work, so it's rejected. Plug 4 in, it's good. Alright, have a good day.